today to welcome Hunter Horton, who's a senior software engineer at Keysys, and he is going to talk to us about some great React patterns to make our code better. So I'm really looking forward to hearing from him. And without further ado, Hunter, I'm going to turn it over to you.
All right, cool. Hope you guys got your fingers on your mute buttons, because I'm trying to make this as interactive as possible, so I'm not just screaming at your face the whole time and you guys just kind of zone out. So let's see. I'm going to start. We're going to start with like a slideshow type thing where I'm going to go over some solid basics. So I guess a question that I have for the gallery at large is, how many of you have heard of solid before? And generally, how familiar are we as a group with it right now?
Very familiar.
Yeah, only heard it mentioned a couple of times.
All right, so sounds like we got at least a little bit of difference in experience levels. So
I'm supposed to know about it. How about that?
So yeah, so we're going to start in the fundamentals of solid, and then once we kind of have our heads wrapped around what solid is, we can have a little bit of a workshop that I'll show kind of how we can apply that in our React code. So I guess the fundamental thing that we need to know is what is solid. Solid is actually an acronym. And so it stands for S is the single responsibility principle. O is open closed principle. L is the Liskov substitution principle, which is obviously something everybody just knows. I is going to be our interface segregation principle. And D is dependency inversion principle. And so this is kind of just like an outline for when you're writing code and you're thinking about what your code should look and feel like. These principles will play a hand in how you kind of go about doing that. And they're not like, you know, individual rules. Like you can't say, you know, I'm following S here and I'm following L here. A lot of times, if you're writing good code, it'll have a lot of these attributes for whatever you're doing. I guess next, these principles don't really mean anything just by their name. So I'm gonna go through and we'll talk about each of these individually. So the single responsibility principle, and this is gonna kind of be a brief overview because, you know, there are 300 line or 300 page books out there just about solid. So there's definitely a lot of stuff you can dig into, but hopefully I can give enough details that we know what we're doing. So formally, the single responsibility principle says that every module or class should have responsibility over a single part of the functionality provided by your software, and that the responsibility should be entirely encapsulated by either your class, module, or function. And so then all the services of that class should also be narrowly aligned with that responsibility. And so kind of, what does that mean? Really, it just kind of means a class should only have one reason to change. And so if you're writing good single responsibility code, it's going to be code that, if say you're writing something that is all about accounts, right? If something happens and a user changes, our account code shouldn't have to change because it's not responsible for users, it's responsible for accounts. And so that's kind of the idea behind this, is keep everything narrowly focused and give it one responsibility. Some examples that we see in the React world for single responsibility. React components in and of themselves are kind of single responsibility. Their responsibility is to display whatever state of the application we have. Another thing that we'll see is Redux reducers. The only thing they're responsible for is updating the state of the application. And typically those things aren't really mixed. API services. So any of y'all who use services in your React code, a lot of times they should be singly focused to where, you know, they fetch states specifically about whatever the service is for from the back end, and that should be their sole responsibility. So that's just a few examples. Is everybody kind of wrapping your head around single responsibility? Anybody have any questions about it or what it means? All right, if not, we'll move on. All right, we also have hooks. Hooks are a great example because, you know, they're a single function that is responsible for doing one task, and typically your hooks live by themselves. So if you can write good hooks, you're nailing a lot of this. So an example of a hook would be the use state, and all it does is maintain that state, right? So open-close principle is the O in solid. Our formal definition is software entities such as classes, modules, functions should be open for extension but closed for modification. What that means is you should be able to add new functionality to your class or your module or your function without having to introduce the risk of changing its existing behavior. And some examples of how this rule can be applied are going to be like class inheritance, right? So if, for instance, we have a class like the timeout service, and it doesn't quite do what we want. We're dealing with promises a lot in our code, and we like that kind of pattern. Instead of, you know, wrapping timeout service and then adding functionality in the wrapper, instead we can actually extend our timeout service class, make it the timeout promise service, override what it's doing, and you know, get that same functionality without having to actually touch the source code itself. Coding to interface is another good example of open-closed. If your React component has a dependency on a service, such as like a HTTP service, you should abstract out an interface for that service, such as the HTTP service instead of just HTTP service. And that's going to allow you that when your requirements change, because they will, the component is open to changes in the service, but it is closed to changes in what that service, the specification or the API of that service, right? So that allows you to be unaffected, and you're decoupled away from what your services are doing compared to what your views are doing, your components. The children prop is also an example of open-closed. So you can use it to inject different functionality into your component without needing to change your component, right? So it's open to different functionality, but it's closed to change in how it works itself. So any questions about open-closed? Feel free to type stuff in the chat if you have stuff you just don't feel like talking. So next we got our Liskov substitution principle. Before we actually dive into Liskov, I'm going to warn that the formal definition is a little hairy and your eyes might glaze over. But it says if S is a subtype of T, then the objects of type T may be replaced with objects of type S without altering any of the desirable properties of the program, such as correctness, task performed, etc. So what does this mean? Really, it just means if you're extending a class or implementing an interface, your new class must be able to be used everywhere that the parent class or the interface is used without having unexpected consequences or side effects. So if, you know, if back in the older example, if we have a timeout service and I extend it to be a timeout promise service, I should be able to use that timeout promise service everywhere that I would have used the timeout service, or else I'm violating this principle. So some examples of this, we have an HTTP service, right? We get some new requirements come in. They're saying our front end is, you know, making too many requests to the back end. The terrible back end engineers obviously don't know how to handle all these requests. So now we have a solution, right? We need to cache some responses to data that isn't going to change, but, you know, maybe once a day, something like that. So so now we have some components that are going to need access to live, up-to-date information. We have some components that are going to need some cache data so that they're not chatting with the backend all the time. So currently, all of our components are using this HTTP service, which is the live one that doesn't cache any data. So the first thing we need to do is look at our past design flaws and how we should have used an interface instead of relying on a concrete implementation. And after we've done that, we'll have a weep because we've made the wrong decision. But once we get past that, we got a pretty easy solution. All we got to do is create a new HTTP caching service, and it's going to extend our HTTP service. And so now we have our extension, our child component, and we can override the methods for HTTP service, and we can add caching to those methods. And so now everywhere that needs caching, we give the HTTP caching service, and everywhere that doesn't, we just provide the normal HTTP service. And so these components have no idea that they're dealing with the HTTP caching service, but they are. And so we get kind of caching for free, if you will say. And so the next in Solid is I, which is interface segregation principle. Formal, it is many client-specific interfaces are better than one general-purpose interface. I think that's kind of easy to understand, but it really just means a client should only have knowledge of the methods it is actually going to need. And we have a special case in this one because there's an even easier metaphor we can use. If I want a banana, don't give me a gorilla holding a banana, right? Just give me the banana. So we can apply that in our React code. This is the origin story of the interface segregation. So it's in the 90s. You're working at Xerox doing your thing. And you know, you think you're so smart, I'll write a job class, and the job class will be responsible for doing the stuff that a printer can do. It's the job class. Problem is that, you know, the printers start to do more and more things, and your job class is exploding in size, and suddenly it's impossible to change the job class because, you know, there's thousands of lines, and each change, you know, cascades into 40 other things. So our boy Robert C. Martin comes in, and he's consulting for him at the time, and he says, I think I can figure this one out. So the interface segregation principle is born. He creates new interfaces for each type of job that the printer is going to perform. So the staple job, the print job, they all get their own interface. And so from there, he makes classes that implement these smaller interfaces. They wrap the job class. So staple job will implement iStaple job, so on and so forth. These wrapper classes are then going to call into the old job class, which we can deem pretty much legacy at this point. It's a black box. But this job class also implements all these smaller interfaces. So what that means is that the new functionality for the staple job or the print job and all those things, they're written in our smaller classes that we've extracted. Old functionality still lives in the job class. So finally, things that need to know about stapling only know about stapling. Things that need to know about printing only know about printing. All is better. Changes are able to happen a lot more fluidly. So that's the origin story. Where do we see this in React? We see this in Redux reducers. If you look at the combined reducers, when you're writing Redux reducers, we can segregate each reducer so that it only acts on the actions or the state of a single logical unit. That way you can have your account reducer, your user reducer, and none of those things have to touch each other. They can kind of live their own little life, and people that need to know about accounts only know about counts, and people that only know about users only need to know about users. A bigger version of that is kind of React versus React DOM. So the separation of React and React DOM is a large-scale version of this principle. React is responsible for our virtual DOM and translating JSX and giving us all the, you know, components and stuff that we're used to. But then React DOM doesn't care about any of that, and all it is used for is for actually doing the DOM manipulations, right? And so they've kind of applied this principle to say we have two separate libraries because they have two separate purposes. It's also single responsibility, right? Interface segregation, single responsibility are typically linked together a lot because, you know, they're both really about making small logical units. So next in Solid, we have dependency inversion principle. I think this is the one that most people probably have used if they've been on the back end at all, but they may not have even known they've done it. Formal definition is high-level modules should not depend on low-level modules. Both should depend on abstractions, such as interfaces. The second part of that is that the abstractions themselves should not depend on the details, such as the concrete implementations. They should also depend on abstractions. So what does this mean? It means we should be using interfaces for dependencies, not concrete classes. Don't be passing classes around. So this also means that an interface's method signatures should not have details related to specific implementations. So an example of that would be if I have, you know, the I animal, right? I shouldn't have bark on an I animal interface because that's specific to maybe the dog class, right? And so if that leaks up into our interface, we're doing the wrong thing. We should probably have like a speak or a vocalize or something like that that can apply to anything. So this is kind of like what that kind of looks like from a hierarchy. Let's see, I think I have a pointer here. Click it. Yeah, okay. So this is our package. This is where we live. And this is our object. This is, you know, our component that we're living in. Without dependency inversion or the idea of it, we're just going to directly reference, you know, some object B. So this is our HTTP service. We're just going to directly import it and use it, and yay, we're all happy. But really we're not, because if we invert our dependency and instead we point to an interface such as the HTTP service, and the HTTP service implements our interface, then that kind of decouples our package from the HTTP service. That gives us the freedom to not care if, you know, object B, our HTTP service, changes. We don't need to know the details of it. All we need to know is the signatures from that and how we interact with it. And so it also gives us the freedom to use different interfaces, right? So if we are doing our interface segregation correctly, we will have a very small interface, and this might be able to do more things. And if, you know, if all I care about is, you know, reading PDFs or something, right? Interface A might be iPDF reader, and this might be a PDF, you know, manipulation library, but I don't care about anything else. And so if I ask for an iPDF reader, then I don't have to care about everything else that's on this object. It gets me a smaller thing to keep in my mind when I'm looking at all of these interfaces and all of these classes that I'm working with. And so that's dependency inversion. And so that gets us to D, solid, SOLID. Where do we see this in React? So this is kind of where we're going today in our workshop. In IOC, Inversify is a library that is working on bringing inversion of control into the TypeScript landscape. This allows us more easily to not rely on concretes and interfaces instead. And so another thing that has helped with this is our React.context. It's a little bit newer, but I think people are starting to use it a lot more now. They can be used kind of similarly as IOC containers, where you register stuff with your context, or they can even be used in conjunction with IOC containers. And they allow us to provide abstractions in our context, and then we can register whatever concretes we want in the context. So hopefully that makes some sense to you guys. If anybody has any questions about any of that, I think we should take a little bit of time to dive into any of that before we move on, just so that everybody kind of feels good about it.
So Hunter, I have a question. Yeah, I've heard this phrase said a lot in the React world, composition over inheritance. Does that, how do you see that in relationship to what you're talking about? Maybe it doesn't have anything to do with it, but does that fit in here in any way? And how can you kind of help unpack that a little bit?
Yeah, so this is kind of the world of programming in general is realizing that inheritance can lead to many terrible things, right? And so composition over inheritance essentially just means instead of relying on, the animal class, and because I am an animal, I'm a dog, right? So I am an animal. So instead of relying on animals and stuff like that, we shouldn't really care what it is. It should be composed of different things. And so that kind of leans more towards interfaces, right? And so we'll say, I don't care if you're an animal. I care if you have the ability to bark. And so that's the composition of an object instead of the inheritance of where it came from or what it is. I don't care. It's the composition of an object versus where it came from, essentially.
Yeah. And solid definitely pushes you more towards composition.
Yeah, I see that. That makes a lot of sense. And I like that phrase, if I don't care if you're an animal, I just care that you can bark. That's a good way of putting that.
All right, well, if everybody else is satisfied with solid, we can move on to the workshop where I've kind of set up a hopefully solid base for people to be able to look at and see how this might be implemented. So I will stop sharing the window there, and I will instead share my WebStorm. Share, where are you, WebStorm? There you are. All right. Is everybody seeing my editor?
Yes.
Okay, beautiful. All right, so we'll take a tour through this little app that I made trying to focus on solid principles. So just from like a layout perspective, I started out with a create React app, and so it dropped in my index TSX for me. This, of course, really is just a wrapper to get into our main component, which is our app component. And if we want to see what our glorious component looks like, let me pull that up. Oh, I got to share, I guess, my whole desktop if we're going to see that. All right.
Andrew, do you mind zooming in a little bit too?
Yeah, for sure.
Awesome.
Let's see. Okay. So hopefully y'all should see my browser now.
Yes.
All right. So as with every other demo of React, I've decided to do a to-do list because it's so easy. And you'll see these are coming back from a backend. So if we refresh our page, no to-dos while it's loading, and then bam, we're coming in. These are auto-generated just randomly. So if you see anything in here crazy, I didn't put that. That's just what comes. So, all right. So here we go from how we got here. So in our app, I have, like 5 lines of CSS to get us flexboxed into a centered. And then we have our to-do list component. Then inside of our to-do list component, this is where hopefully the solid fundamentals can be seen. So we're using a context. This context is to house our services that we might need. And so in order to get our to-dos out of our context, I told you I was going to zoom in, and then I totally didn't. Let's see. Editor. Let's go up to 18. All right. Everybody see better now?
Yes.
Okay. So out of our context, we're going to grab our service container, and we'll go into this. So this is Inversify. So I've created a interface called the iService context, and in that service context is going to live our Inversify container. And so Inversify is just like any other IOC that you may have used in the past, except you have to use Typescript because a lot of this IOC stuff only works because of typing. So we'll go into our container. I think that is going to be in our IOC config. So here you'll see we create a container, and then we're binding, which is an IOC way of saying I want this service to, whenever I ask for my types I-to-do service, I should get to-do service. Whenever I ask for an type IHTTP service, I should get fake HTTP service. And so these types are an Inversify way of making sure that what we ask for is the same. And so it's using the symbol. I think this is part of maybe ES6. They created the symbol. So symbol.for, and then you give it the string, and that should give you a fast way to compare things. So instead of doing like string comparison, asking for a I-to-do service, this gets broken down into essentially like a hash, and then it can compare those hashes really quickly. And so we'll do an app container.bind. So when I ask for this, I get this, and then we're exporting our app container. And then where we're registering is in here. So this is at our root level. We have service context.provider. I'm sure we've probably seen context before, but this is a way of saying for the service context, I would like to provide this value. And so I use my iService context object here, and I give the app container, which is what we just registered in our other one, to our service container. And so that means that when I go inside of my app, or my to-do list, rather, when I say service container and get this, we've already registered that as the to-do service concrete. And so this decouples our component from having to know what kind of to-do service it is. It just needs an interface that behaves the same way. And so then for that service, I say get my to-dos. When I get them, I set them in my state, and then I display them, right? So that's pretty standard React stuff. But then, so in our services, we have to-do. Our interface is pretty simple. We just have to-do service. We'll have get to-dos declared as a function, and then it's just going to return a promise of strings. So our service itself, for Inversify, we're going to be using these annotations. And so injectable just means I am able to be injected somewhere. So that just tells Inversify that it can be used. And then this inject says I'm going to need an HTTP service, but I don't necessarily need a concrete HTTP service. Just give me an iHTTP service, and I'll use whatever you give me. And so you'll notice in our config that we are registering an iHTTP service to be a fake HTTP service because I didn't feel like writing a backend. So instead, I wrote this fake HTTP service that is just going to generate random data, do a timeout to pretend like it's, querying stuff. A second, hopefully it doesn't take that long in real life, but then it returns our fake stuff. And so by abstracting this out, our to-do list doesn't know that it's getting a fake HTTP service. It just is getting an iHTTP service. So that could be real, that could be fake, that could be caching. It doesn't need to know those details. It just needs to say something that implements this interface, give it to me. And so that's what this line's doing. And so by abstracting stuff out like this, it's also going to make our tests a lot easier to write. And so if we look in our to-do list and we look at my test for it, first thing you'll see here is when we don't have a to-do, then I should expect to see this on the screen, right? And so mock to-do service, I pulled this out because both tests are using it, but you just pass in what you want it to resolve to, and then it creates a fake I-to-do service. You don't have to create a to-do service, you just have to give it a function that implements I-to-do service, right? And so that allows us to not have to provide a concrete to that class. And so we're not locked into using a HTTP service. We can provide it a fake I-to-do service that doesn't do anything with a HTTP service. And so now that we have our mock, we grab a container, we do the same thing that we do in our config, we bind our I-to-do service to our mock that we just created. And so we use toConstant value because it's just an actual const instead of a class. So previously, when you use to, it registers it to a class, but toConstant value just means it's a variable. So I wrap it in an act call, I render it out, and in order for my context, I just create another provider for it and give it my container, which contains my mock, and then I call to-do list, and then it's as easy as saying, let's make sure my empty thing is there, and once it is, I assert that it's the same string. And so you'll notice that by decoupling all this stuff, I'm able to provide fakes for pretty much everything really easily. And so your testing is going to get a lot easier because you're not going to have to write as many integration tests. You're going to be writing actual unit tests because you're able to mock out everything that is a dependency. So same thing for actually getting our to-dos. The only difference here is that I'm resolving it to a bunch of randoms and then one that I expect to be there. And so when my to-do service is called, it's going to return all the random ones and then the one that I am expecting. So I do the same thing here, and then I just make sure that at some point my expected to-do shows up on screen, and then I do my assertion after that. So it really does make testing super, super easy. And another cool thing that I'll mention with using like a IOC in context with context is because the, let's see, where's my to-do list? Here it is. So because this use context here, because this by nature is going to look for the closest provider of the context, every single portion of the app that you have can be provided different containers, right? And so right now, we're wrapping the whole thing in this service provider. But if for some reason I wanted to provide a caching service for my HTTP service instead, say my to-do, where is it? My to-do list here. Say to-do has some, some special thing, right? Where it needs to get some cached something from somewhere. All we would have to do is wrap our to-do in a different, where is it? Service context dot provider, and then we can say value is equal to, get rid of that, do that, format that, okay. So now we provide a different container to this guy, and so if he asks for a to-do service, and I provide a different one here, a different container, then he's going to get a different service than I am, even though they're both going to be using the same context of service context. Because this provider is closer to to-do, he's going to get whatever I put here. And so this allows you to switch out whatever is in your container really easily without having to work and jump through a bunch of hoops. You just put it, provide it in a wrapper, and it's good to go there. Does anybody have any questions about anything? How I'm doing stuff, why I would do stuff certain ways, Anything like that?
I'd also be interested in hearing if anybody else is using Inversify currently.
I'm not, but I'm going to check it out after this.
Yeah, I will go over one or two pain points with Inversify that I'm currently running into. You'll see that first off, having to do this types.ihtb service, that currently is required for React because of the way the collisions work. So normally I should be able to say just do an empty bind. I should be able to say this. And it can pick up the IHTTP service generic argument here and then just say to and then give it a concrete, right? But right now that's not in the cards, so we're having to do these types with the symbols to be able to drill down to one thing. But they're talking to TypeScript people and they're working on getting it to where you don't have to have these types anymore. Another corner that I'm getting cut with is in our to-do service. You'll notice that this is property injection. So it's injecting into here instead of, I had to put this TS ignore because TypeScript gets real mad. It's like essentially, this is auto magic stuff that should never happen. The real reality of how we should be doing this is having a constructor, and then we can do the same thing in the constructor. It's also going to make this easier to test. But right now, the Inversify and Create React App are fighting. Create React App doesn't let you have annotations in your constructors. It just blows them away and doesn't keep track of them. So if you're not using Create React App, you can get around that because you have control over your Webpack. You can add a couple of Babel plugins and it'll preserve that stuff and it works just fine. But if you are using Create React App, you have to use the property injection right now.
So for testing, what do you see as the advantages of using Inversify for dependency injection as opposed to using just .mock?
Yeah, so just.mock is, it's fine, and you can use that even with Inversify. The only advantages I see are that jest.mock is kind of auto magic, where it's like pulling stuff up to the top and hoisting it and overriding to say, okay, this is now the biggest thing, and override everything else. Whereas with this and in containers, you're not having to worry about any of that stuff because each of your tests is able to register its own container and provide that to the actual component. And so it's a lot easier to do your mocks that way, at least in my opinion. Yeah, and so this is what I think we were talking about, where I can just create, a fake I2Do service right here and then have it return whatever I want. Instead of having to do just.mock and give it the real thing, and then by giving it the real thing with a just.mock, it's going to hoist it all the way to the very top, and then you'll have to override stuff later if you want to change functionality.
Yeah, or maintain a separate, file structure for your
right, or yeah, have the
mocks and all
mocks
that,
folder, which can be a nightmare. Does anybody have any other questions? Do we have, in the chat, who in here is using context right now in their React code? So we got at least a couple contexters. So, and of you guys who are using context, how many of you guys are actually using Redux too? Okay, so more context than Redux. Interesting. So yeah, this doesn't require any Redux. The only thing I'll say is that if you introduce Redux, there is, and you're going to use this type of architecture, then I would say that you should probably look into a library called Redux Thunk, which lets your action creators kind of turn into a service layer itself. And so all it does is say, instead of dispatching straight actions, you can also dispatch functions. And so when you dispatch a function, it acts as a middleware and intercepts that function and then executes it. And so it lets you have asynchronous actions. And so we found that using it has taken a lot of pain away from testing and a lot of pain away from generally using, like, a lot of the Redux stuff is tough because you got to figure out a way to bind your component to Redux, but also decouple it enough to where you can get stuff like, so like, we're trying to get away from having our services and stuff directly in our components. And so this was one approach. This is the one that, going through getting ready for this, this seemed easier than pulling in Redux and doing all that stuff. So this is a way of doing it for sure. I'll say if you go this way, you should be careful that your to-do service handles most, or whatever your service is that you get out of here. It should handle most of the stuff and leave your component to follow the single responsibility, and it should only be responsible for display stuff. It shouldn't be handling HTTP errors. It should not be dealing with exceptions. Like, that kind of logic isn't part of displaying stuff. The only stuff that should be, the only logic in your component should be displaying or manipulating, reacting to user input for displaying stuff. Or maybe, calling a service to get stuff to display, but it shouldn't be in charge of any of those other side effects. That's not its domain. But if anybody, no more questions, I'll stop sharing and give the floor over.
Great job, Hunter.
Yes, thank you so much. That was a lot to chew on. Hunter, are you, or could you push that code up to a repo that you could share with everybody?
Yeah, absolutely. I'm gonna put it on my GitHub and then I'll share that link out.
Great. So just to let you know, everyone, we did record this lecture, and so we do have a React Birmingham YouTube channel that I started last time.